A circular coil of 20 turns and radius 10 centimeter is placed in a uniform magnetic field of 0.1 Tesla, normal to the plane of the coil. If the current in the coil is 5 ampere, what is the total torque on the coil, total force on the coil, and average force on each electron due to the magnetic field? The coil is made of copper wire and the cross-sectional area is 10 to the power of minus 5 meter square. The free electron density in copper is given to be 10 to the power of 29 per meter cube. So N is equal to 20. So R will be taken as 0.1 meter. So B is given as 0.1 Tesla. I is equal to 5 ampere. There is a coil which is having about 20 turns. That is what is given. So this is the axis and this is the plane of the coil. I hope you are able to understand. It is like this. It is along the perpendicular to the board. So this is the plane of the coil and this is the axis of the coil. The magnetic field is perpendicular to the plane of the coil. So plane the magnetic field is like this. It is perpendicular to the plane of the coil. So if I want to take the angle between these two, the axis is going like this. The magnetic field is also going like this. So the angle between the magnetic field and the axis of the coil is going to be 0 degrees. So I can directly take that theta as 0 degrees. So that for the torque is tau is equal to N I A B. If there is a theta coming, it will be sine theta. If it is given as, instead of giving the current and the area, if they have given the magnetic dipole moment, then in that case this NIA totally will be replaced and there will be only a small letter m coming in the place of this Ni and A. But in this case, because they have given the number of turns, they have given the current and also they have given the radius, and from that radius we can find the area of the coil. Now, but we also know this thing, and there is a sine theta, and if I apply that sine theta to this one, the coil is already in the plane of the magnetic field. The net torque on that coil is going to be 0. But again, if you want, just you can go for the calculation of area. A is equal to pi r square, that is going to be 3.14 into 0.1 square, that gives us 3.14 into 10 to the power of minus 2 meter square. That is the area. Then going for the torque, tau is equal to N I A B sine theta, and then N can be substituted. 20 into current is 5, area we found it to be 3.14 into 10 to the power of minus 2, magnetic field is 0.1 into sine of 0, and this is going to give us a 0 torque, that is 0 Newton meter. So this is for the part A of the question. So the coil is present and the axis is already aligned to the field. The force acting on one side will be equal and opposite to the other side. Again, the net force on the coil will also be equal to 0. As done. So force is also equal to 0. Now coming to the third part, we need the number of electrons. That is given in the question. I can take it as N is equal to 10 to the power of 29 per meter cube. A is equal to 10 to the 5 meter square. So that is the given data in the question. Now for the force on each electron. Force on each electron means it is going to follow from the equation of force on a moving charge. So when the electrons are moving inside the coil of that conductor, they are going to be moving with a particular velocity which we had called as the drift velocity, and that drift velocity will be proportional to the current. The equation which we had dealt was I is equal to N E A V D. From the Lorentz force equation, what we have here is it is going to be Q, V, B. Out of these three terms, two of the terms needs to be changed. First is the charge of electron. This V is going to be extracted from this equation for the current, because in the question the current is given. They have not given the drift velocity, but what they have given is the current and the area is given, N is given. So what I can do here is I will rearrange this equation for VD. It is going to be I divided by N, E and A. Rearranging this equation, so V is going to be VD and there is a B, that is the magnetic field. And replace this VD term with this one. So it is going to be E into VD is going to be I divided by N E A, and then there is a B. And so directly substitution E. Okay, before that, this E and E can be cancelled. So what I'm left with here is only I into B divided by N into A. So I'm having less number of terms. I, the current is given here, it is 5 ampere into the magnetic field is 0.1 divided by N, the number of electrons, 10 to the power of 29 into the area is given as 10 to the power of minus 5. That is going to give us 5 into 10 to the power of minus 25 Newton. So that is the force on each electron.